All right. Just want to make sure some things. If you got a microphone, you can turn it on and ask a question. If you don't, there's a chat box there that you can type in a question if you have any, okay? Bree got started. She wanted to look at a problem that had a quadratic or a parabola. All right. So we are looking at problem number 69. And so what we're looking at is, it says put it in standard form, but we know that, that this is what we traditionally call standard form. So what they're saying is they want it in the form of a equals x minus h squared plus k, right? All right, so you've got the h is going to be negative b over 2a, right? So you've got a equals negative 2, b equals 8, and then c equals negative 10. So what we'll do is it'll go negative 1 times 8 over 2 times negative 2. So that's negative 8 over negative 4, which equals 2. All right, so our h value is 2. So that's the x coordinate of the vertex, right? That transition point. So in order to find the k, we have to take this 2 and we have to plug it back into this main equation up here. So that would be negative 2 squared plus 8 times 2 minus 10, and that would be negative 8 plus 16 minus 10, so that's 8 minus 10, which is negative 2. So our vertex on this is 2, negative 2, right? And if we write the equation, it'd be y equals, the a is the same a in both forms, okay? So that'd be negative 2 x. That's a positive 2, so when I plug it in the equation, it will become a negative 2 squared minus 2, all right? So taking it from standard form, putting it in vertex form is something that you'll have to do. You'll have to know how to get the vertex, which in this case, because the a is negative, it's opening down, which means that it would be a maximum, right? So they'll want to know, if you can get the maximum. And if you remember, you have really two options for that. You have y equals negative 2, which is the y value or the k there, or you have, if it said max and it actually gave you ordered pairs, then you would put 2 comma negative 2. Okay, so just know that that is an option. All right, either way would be correct. Just depends on, it's multiple choice, so therefore you'll know what form it needs to be put in. It's no guessing. Okay. What else can they ask you about that? They can ask you about shifts, right? So if we look at this right here, from a quadratic transformation standpoint, it's going 2 to the right and 2 down. It's being reflected and it's getting closer to the y-axis. So if we think about this as being our x squared, right? So what's happening here? It's being reflected, which means it'll just open downward, and then it's moving 2 to the right and down. So it'll be down here, right? Okay. So that's kind of from a transformation standpoint as well. Going back up, looking at this quadratic, just some things, and I put this out in an email today, but want to kind of reiterate it. You have you have to find the zeros of that. Okay, and what that means, where does it cross the y-axis, which would be just plugging in the quadratic formula, right? So that's always an option that works 100% of the time. Okay, so all right, I think that's just about everything I can kind of do with that. Any more specific ones, Bree, before we go to another problem, take another person's questions?
None that I can think of now. Thank you.
All right. Okay. Jay, Rebecca, y'all got anything? You can either, let's see. Rebecca, I mean, do y'all see the little chat box? You can always type your message in there if you don't have a microphone. So okay. Well, let me talk about something real quick while y'all are thinking about which ones to ask. What the heck did I do with that? There we go. So there's two questions. Okay. Can you run through some on the imaginary number questions? Jason, which one you talking about? Okay, like 36. Okay. So let me go here. Final exam review 36. Okay. So 36 is radicals with negatives. They're going to talk about adding or subtracting them, right? So let me go to this, make this go there. I'll go back to here. I'll grab 36. I will tell you 35 is a really, really good problem. I'd make sure I could do problem number 35 if I were you. All right. Hint. Okay. So what we have to do on this, we've got negatives underneath our square roots, which in case we know we can't have. So we know we can do, basically, we can rewrite it as -1 times the square root of -1. And then what this thing is doing down here. Times the square root of 4. Okay, so that's taking care of that first part right here, right? Then we'll change colors. Minus 4. That looks like a 9. I don't have my little writing pad. I left it at school. So I'm having to use a little pen that's not traditionally one that I like. So forgive me on the sloppy handwriting. All right, so that's times the square root of -1 times the square root of 25. Okay. Now, so we know that this is going. Let's kind of take care of this first. Okay. So -1 times, and this is going to be I, so it's -1 times I times 2. So what that's going to be is -2I, right? So let me do this. All right, now we can get back. And then down here we have, that's doing that. -4 times I times 5, right? So that's -20I. And these combine to give you -22I. Okay, so, so looking here. Nope. All right. So that's that one. So, so Jay, did that help you a little bit on how they got -22I? You got to split it. If they didn't have negatives under there to make it an I, then I would look for common radicals in order to add the coefficients of them. Okay. I just want to make sure that everybody has looked at the email that has this document on there. Properties of exponents. You're going to have to solve, or I should say simplify problems that have exponents on them, right? So if we look at this, what am I talking about? Well, guys, I'm talking like problems 5, 6, 7, and 8. Those are problems what I'm talking about as far as properties of exponents. Okay. Quadratic equations. I would look at, when you look at a quadratic word problem, you're talking about whether something hit a maximum or something hit a minimum as far as production. You're also looking at one kind of like another one, a real good one is see here, like 72. The ball's thrown in the air. How long does it take to reach its maximum height? And then how long does it take to get to the ground? The other thing that they can say is, besides the maximum height, how long it gets to the ground, is this. How long does it take to get to a certain height? And if you were to do that, you would take this quadratic, which is, go here, this quadratic right here, and you would set it equal to the height at which they wanted to, and then you'd move it over. You'd move that constant over, right? So if they said, hey, if it's equal to 60 feet, right, then you would move that 60 over and then solve the quadratic from there to see where, at what time it would be at 60 feet high. So that's kind of, 72 is a real good one. This 73 is really good as well. So, trying to think of which other ones here. Turn that back off. Well, schnizzle. It ain't gonna let me. Oh, okay. All right. All right. Let's go back and clear that off. Erase all drawings there. Solving cubed and square equations, square root equations as well. So direct and inverse relationships. On this right here, what I'm talking about is, can you find a relationship that varies directly, or can you find a relationship that varies inversely? And so, or it could be like the first 6 problems in the homework, which was said, write the equation, right? So it could be something like that. Operations with complex numbers. I gave you that problem, a plus bi, and then you times, like multiplying complex numbers would really be a good one. Dividing complex numbers would also be a real good one. Solving, what I mean by solving rational equations right here, what I'm talking about is an x raised to a fraction of a power. Okay, that's what I'm really talking about. So just know, we worked a couple of quadratics that look like that in the rational equations and stuff. Perimeter word problems. We looked at some perimeter word problems where it gave a relationship like x, the width is this, the height is 3 or 4 times the width, and the perimeter is this, solve for the width, right? So that's kind of word problems that you may see. Distance and midpoint. Find a distance between 2 points, find a midpoint. You'd be asked to do that. Little equations would be solving, here's an equation with a lot of variables in it, solving in terms of that variable. Those are things that we did at the very beginning of the year. Evaluating piecewise functions in terms of function notation, like f of 5, f of 2, looking at a graph or looking at an equation. So just kind of, that's what I'm talking about when evaluating. Rate of change for intervals. I tell you, I looked at boom, boom, boom. 73 is a really good problem for that. Here's a formula. Find the average rate of change or the average velocity from t equals 1 to t equals 2, right? So really what you're saying is find the rate of change. Those T1 and T2 right here on 73 is actually X values. So you'd have to plug them in and get the outputs and then find, of course, the rate of change. Writing linear equations, anything that deals with, here's a rate of change and some starting point, kind of like, let's see, the telephone questions where it was like comparing who had the best telephone rate in so many minutes and stuff like that. I want to say that was chapter 4, but it could have been chapter 3. But anyway, that's what we're talking about. And writing linear equations given a point and a slope or 2 points or anything like that. So perpendicular and parallel line linear equations, meaning if you remember, we went through that section, write an equation if it's parallel to this one but passes through this point. Write me an equation that's perpendicular to this but passes through this point. So that's kind of what I'm talking about with those. So just kind of be aware of that. Evaluating functions with function notation, tables, graphs, and equations. We did those with chapter 3, chapter 4, I think. So compounding and continuous interest, I think that's all 6-1 stuff. Continuous has the E, right? Compounding has the 1 plus R over N raised to the NT times the P, right? Some expanding and condensing logs, even some solving logs, right? Very, I wouldn't say too hard of a problem, but remember we looked at solving logs two ways. We were able to get it back into a exponential and then get the bases to be the same. But we also had to solve the log where the of was x, if you remember that. So kind of make sure y'all understand what I'm talking about. Like log 3 of x is equal to some crazy number like 15 or something, you know, where you would turn around and take that and you basically do a backwards C, right? And it'd be 3 to the 15 equals X, right? So anytime you have that of as an X, that's something that you need to kind of be aware of or be able to do. Remember, there's two ways that we were doing that. And then we finished the other night. We had two exponentials. Let's just kind of say 2 to the X equals 5 to the, yeah, okay, 5 to the third or something like that. You know, we take log of both sides of those, right, and solve those because we can't get 2 and 5 to be the same base. So that was the other look for the exponentials. Solving and graphing absolute value inequalities. I think that was chapter 3. Pretty sure it was. You're going to have to know how to do the compound inequalities, the ands and the ors, as well as the absolute value ones. Okay, those are really good potential problems. So make sure that you can do that. Know the difference that an and has two compound inequalities if it's in set notation, right? And if it's an or, it'll tell you. But also make sure about the absolute value, right? We talked about absolute value. Great or, right? This is an or. And then absolute value less than is an and, right? So that's how you tell what type of inequality you have when you have an absolute value. Yeah, I think that's about it on that. Yeah. All right. Shifts on functions, quadratics. Kind of hit that the first thing. But do you know when it's reflected? Do you know when it's vertically stretched and stuff like that? Scientific notation. You're going to have to know. You know, can you take, you know, a number like this and put it in scientific notation? First of all, it's a big number, so it comes from a positive exponent, right? So 1, 2, 3, 4, 5, 6. So, you know, 2.53946 times 10 to the 6, right? That's a positive because it's a big number. And of course, if it was something like this, then we know that we would have, when we write it in absolute value, that it would be 1, 2, 3, 4, 5. Uh-oh, I don't need 5. I need what? 4. 1, 2, 3, 4 right there. Let me go ahead and erase that. Yep, right there. Because we're looking at 2.3, the number in front of the decimal needs to be a number between 1 and 9 times 4, and it's negative because it's a decimal, right? So just kind of make sure you're able to write them in and out, and then multiply them or divide them. So just kind of make sure you can do that. Other things, graphing quadratics. Make sure you can graph a quadratic. You know, if it says here's a quadratic, what graph matches it? Then of course find the vertex, right? The vertex is going to be the transition point, right? Let's see. Yep. And also know, I mean, they give it to you in two forms, I guess. They could give you something like, well, I don't want that, I want this. Or they could give you something like this, right? Just kind of know that if they give it to you in standard form, that this is the y-intercept, right? So that's something that I'm looking at. Okay, where's it crossing the y-axis? Because if I got to tell what graph is this, right, then I'm only going to look at graphs that cross the y-axis at -6, right? Then the second thing I would look at is, what is my A? My A is a +1, right? So it opens up. If it was negative, it would be opening downward. So I would look at that as well. And then if I needed to, if I wasn't able to clearly be able to pick one off that, then I can look at the graph and grab a point, an X value, plug it in, and see if it gives me that Y. You know, that would be an easy way to do that. So let's see what else. Characteristics of an absolute value equation, domain range, increasing, decreasing, max and min. We looked at a parent function of a quadratic, not a quadratic, an absolute value. Trying to think here. Bum, bum, bum. Yep. Nope. Yeah. So let's kind of look at it, just grins and giggles here. You know, if you're looking at, if we're just looking at y equals absolute value, we know that it does this, right? So our domain would be -infinity to +infinity, right? But our range, well, it's right there at 0, right? So our range would be this. Okay, so that's, and of course, increasing it's decreasing from -infinity to 0, right? It's decreasing, and then it's also increasing from 0 to infinity, right? It's got a minimum at 0, 0 because it's, you know, a V, but those are things I would make sure that I understood, you know, especially, you know, the range and stuff like that, because it follows very much like the quadratic, right? The domain is going to always be -infinity to +infinity for those, but the ranges are, you know, if it's just a parent function, it's 0 to infinity, and if it's opening downward, either one of those, it would be the opposite of that, right? Let's see what else. Write an exponential equation using 2 points. That was one we done the other night. We give you 2 ordered pairs and say find the exponential, right? Make sure you can do that. Simple interest problems. Make sure you can do those. There's kind of you put so much in this account at 5% interest, and then so much of this account for 5% interest for X amount of years. Little simple linear ones. Systems of equations, substitution or elimination. Make sure you can do those. And then what makes a relation a function, right? A relation is a function if the x's don't repeat, right? So just kind of make sure that that's very much secured in your brain. And if you do that, then you should be okay. You know, again, it's kind of what you possibly could see and whatnot. So, all right. We got a request to look at problem number 74. So let's kind of look at that. So that kind of goes over the email that I sent last night. You know, content-wise, that stuff that you could see. The other thing would be just making sure you could do those type problems on the final exam review, right? So if you go, well, I didn't write down kind of what you're talking about, well, this will be up in Blackboard, and you can listen to it and rewind and look at it and listen to it, and then kind of write stuff down and get a better, more focused review. So let me go to 74 real quick. The cube of, okay, so make sure that goes there, here. All right, so y varies inversely with the cube root of x, right? So if we talk about inverses, then if you remember, it was the equation was y equals kx, right? K over x, right? So if we looked at it, we did it like this: xy equals xy. So if they want you to do the equation, you got to be looking at this type of format, right? Where you solve for k, and then you put it whatever k is. But if you're given like this is giving us, it's giving us a set of points and then another relationship, then we're going to have to look at it in terms of this. So y varies inversely with the cube root of x. So it will be the cube root of 27 times 5 equals the cube root of 125 times y. And when you do that, the cube root of 27 is 3, so 3 times 5, that's 15. And then the cube root of 125 is 5, so that's 5y. And then, of course, you should see that, we divide both sides by 5, and we get y equals 3, right? So if we're looking at this, 3 is the answer, right? But if they ever wanted us to tell them what the equation was, when you do this x times y, you're getting what k is, right? Because this is k, so you're getting, so that would be 15 over x, right? So because there's your k, and then 5 times 3 would be 15. So your k's have to be the same, but that would be the equation if they ever asked you that. So you've got really both of those that you could look at and make sure you could do. Okay. All right. Could we review an interest problem? Yeah, but hold on for a second. Let's see. We got Brenda, Bree, Jason, and Rebecca. So let me unmute. Anybody got anyone that they were looking off on the final exam review that they were looking at that they were like, I'm kind of stumped on this. This is kind of one that you want us to look at, but I still don't understand it. So let me take those before I answer Bree's other question, okay? Y'all got one? Put it in the chat box, or just turn your mic on and you're good to go. Let me know. I'll wait on you. All right. Well, I guess I should have asked, can everybody hear me? But I guess so, since y'all just put that. Can you go over how to graph a quadratic one more time? You want just a basic like this. Something like that. Oh, 51. Okay. Sorry. Let's go back here. Yeah, I'd make sure I could do something like 54. And while I'm sitting here looking at problems, yeah, 54 would be a real good one. Let's see. You don't have one like that, so you're okay on that. So don't worry about 51. Okay. Okay. Definitely something like 47. Kind of 47. 46. That's the fourth root. I guess they could do a cube root, right? Or something like that. Of course, like on 38, move the 21 over to the other side, right? So 35 is a real good one. 33 is an excellent one. I'd make sure I could do 33. Anything 25, 26, 27, right? Those are really good problems. Look at 28, because that's really a good linear problem to look at. 23, 24 are really good. I'd make sure I could do 22. Make sure you could do a problem like 22, okay? 18, of course, 19's midpoint, right? 18's distance. And of course, the distance formula is on there, right? So something like 15, all of that. Yeah, 9, 10, 11, 12 through 14 is not a bad things just to kind of brush up on your, especially 13, 14, and 10 for radicals, just simplifying radicals. Properties, exponents. Yeah. I keep going. $49 is, a really good one. 50's really good one. I'd make sure I could do that. 53, that function notation from graph, that's really good one. Of course, I said 54. Domain and range, like 56, from graph. You have to do that, and you got, absolute value or a quadratic, stuff like that. 58's a real good one. 60, sketch and transformation. 62, well, that's an absolute value, but really look at transformations of quadratics. That would really be good. 63 is not bad. 65 is real good. 66 is a real good one. Yeah, 68 is real good. You got to be able to tell on a linear function whether things are increasing or decreasing just by looking at slope and knowing whether it's positive or negative. 67 would really be a really good linear word problem to kind of focus on. That would benefit you. 70 is an excellent problem. You're sketching a quadratic and you're looking at axis of symmetry and all that stuff. I already said 72 there, 73, 74. 75 is a real good one. Uh, 78, but you can talk about semi-annually. It's twice a year, but what if it was quarterly or weekly? Quarterly, the end would be 4. Weekly, the end would be 50, 52. You got to worry. There's one like 82 that's on there. That's one I'll give you, so don't worry about that. Or 83. Expanding, condensing, I'd make sure I could do that. Evaluate this log right here on 88. Evaluate the log on 89 would be good. Exponential, yes, yes, yes. 95 is a real good one. 96, if we'd ever looked at that, but I think 96 maybe y'all can look at that. And 99, 100. 102 is a really good simple interest problem. I'd look at that. And of course 104. 104 if you're looking at some linear, but really the perimeter of a rectangle one is really the most you have to do. So that's kind of things that a more focused view of the final exam that I would make sure I looked at. Again, there's 40 questions and probably about 3 or 4 of them will be cold. So you got about 36 questions. And if you make sure you can do everything that I went over, you should be okay. All right, looking at the final exam review and focusing on that content. And then if you need more practice, go back to those sections where those are and take a look at that and kind of make sure that you're good. Okay. So, all right, I got 9:15. So, y'all, anybody got anything else? Yeah. 47. What about 47? Haha. What to do with that rational exponent, huh? Let me go here. Make sure that. All right, so first things first, if we're looking at this, this is isolated on one side, which is really good, okay? So how do I get rid of that? If you remember, that's really the cube, this is really the cube root of x minus 1 squared, right? Equal to 9. But it's like, what do we do, right? So it's easier just to do this, kind of raise it. If it's 2/3, I can raise it to the 3/2 power, right? And then over here, I'd have to raise 9 to the 3/2 power. So what that does is it gives me 2 times 3, which is 6, and 3 times 2, which is 6. 6 over 6 is 1. So it leaves me x minus 1 on the left-hand side, and then 9 raised to the 3/2 power, right? So if you remember how we rewrote this, it was square root of 9 cubed. So that would be 3 cubed, which would be 27. X minus 1 equals that. And that would be plus 1. So x equals 28. So, all right. So that's how you would work that problem. And that's very similar to like the ones we worked in class. I want to say maybe in chapter 2, maybe in chapter 3. Other equations, that section, the crazy ones, right? So just kind of make sure you really know how to do that. Okay, folks. I think I've given you enough to go and focus on. Again, we have tomorrow at 7 o'clock. Same link. I promise you that I won't be late. I apologize. It just took a little bit longer for dinner than what we expected. They were busier than we had kind of figured so, but thank you for allowing me to move it and still participate. So, all right, guys, y'all, any last thing before we go? Anybody? You can turn your mics on, or you can chat. What about logs? 90. Boom, boom, boom. Yeah, solve it as a exponential, right? Or well, 90 says write in exponential form, right? So we'll knock that one out, and then that's got to be it for me tonight, folks. Because y'all need to go do some work so you can figure out what you know and what you don't know based off what more information I've given you. Okay. This one says to write an exponential form, and of course, the base on this is 10. If you remember, we said the base of the log and the base of the exponential is the same. So that'd be 10. Backwards C, right? 10 to the negative 2 equals 1/10, 100. If you, that's really 1 over 10 squared, which would be, yeah, this side does equal that side, right? So that's it, really this, right? But they are the same because negative power means it's going to be 1 over that, right? So, all right, folks, thank you for joining, and study, work some problems, come back tomorrow for last minutes, and then we'll be done. 7 o'clock tomorrow night, folks. All right. Thank y'all.